right? Yes, see, this is given in CSR examination. So where you will cleave? Above or below? So can I cleave here or not? So after cleaving, here you will get radical, and see, this is acyl radical. Why you are cleaving above side? Why not below? Is it alpha? It is also alpha. Why we are cleaving above side? Why not below? This side can you cleave? No. Why? You will get a stable alkyl radical. Here tertiary is there. That's why I am cleaving above side. Later on, see, here two hydrogens are present. Break one of the hydrogen. This radical, double bond. This hydrogen radical comes from here to here. So here you will get this answer. Can I put double bond here? Double bond. And what next? C double bond O H. But they won't give like this in your exam. Perfect 2D model they will give. So they will give a 5-member ring. 5-member ring having methyl. Okay, here double bond is present. So this is adjacent carbon. So you can write a double bond over here. Okay, so this particular carbon carry methyl. Adjacent of this carry 2 methyl. Then after this one particular carbon, then this is C double bond OH, CHO. Is it right? Is it right? How many membered ring? See, this is 5-membered. Just assume this is 1, 2, 3, 4, 5. 5-membered or not? First carbon carry CH2 aldehyde. 1, 2, 3, 4, 5. Like that you can confirm. First carbon carry CH2 attaches to aldehyde. Then second carbon carry 2 methyls. Matching. Third carbon methyl with double bond. Methyl with double bond. Over. So this they will give in your exam. They won't give this structure. In options they will give this one. Now see this. Here I am writing C double bond O. Photochemically, see, they won't give physical state. Physical state of this molecule they won't give. They will give solvent. Physical state if they not mention, if they give solvent, reaction proceed with carbon intermediate. Break this. After breaking, what is your answer? Here double bond, radical, right? Now break this to one more time. Here already one radical is there. Now here this radical. This radical forms. What is your answer? So here I am writing a radical, and here how many radicals are there? 2 radical and here 1 radical. Can I? This carbon carry how many radicals? 2 radical. Then what is the solvent? Methanol is given. MEOH. On that time break here. So here how many radicals I generated? 2 radicals I generated or not? Methoxy radical, hydrogen radical. This hydrogen radical add here. This methoxy radical add here. This radical join together. So after joining these two, what is your answer? See, here you may expect a 5-membered ring, right? This radical join together and forms 5-membered. Now here 2 radicals are present. What is this? Carbene. Carbon with 2 electrons is called carbene. Now, this hydrogen in the form of radical, this oxygen in the form of radical added on these two. So, can I write this? Here hydrogen and here oxygen, and this is the answer. If physical state is not mentioned, if solvent is given, either ketene, otherwise a carbene, reaction proceed with carbene or ketene. Ketene not possible because it is a strain molecule. If any strain molecule is given, reaction proceed with a carbene intermediate. Okay, be careful. Three possibilities are expected. They will give solvent, they will mention physical state. If physical state is given, gaseous or liquid, in gaseous state decarbonylation, in liquid state Norrish I cleavage at alpha carbon and carbonyl, then transfer of hydrogen from alkyl to acyl. They are most common. Suppose if any solvent is mentioned, be prepared, definitely your answer may be either carbene product, otherwise any ketene product. Transfer of hydrogen, decarbonylation not exist. That you remember. Now these upcoming questions all are given questions in photochemically methanol. What is your answer? Now physical state is not given, solvent is given. Now intermediate is not carbene. In this intermediate is not carbene, but here I given methanol. In this I given methanol. Now intermediate is what? Carbene. So can I break here? See here, methyl is missing. You write down methyl here, alpha carbon methyl. Here I written methyl, see. This methyl is missing. Here I not written, you write down this methyl. But here I written that methyl. So, in starting of this reaction, you write down methyl here. Camphor, it is a camphor structure. In camphor, methyl is present. And here also remains same. So what is your answer? Now here radical, radical, and here methyl is as it is. Now can I break this one? Here how many radicals are going to generate? Here one radical, and see, oxygen one radical, here how many? Two radical, right? When methanol is given, be careful. Your answer is definitely a different product. Carbene product or ketene product. Suppose if solvent is not mentioned, if methanol is not given, ethanol is not given, you are free to attempt either physical state, gaseous or liquid if they will mention. If any state is not mentioned, go for gaseous state. Now see, these two radicals are joined together. After joining these two, can I write like this? These two will be joined and here two radical. Right? Then use methanol. Break this, hydrogen here, alkoxy over there. Here hydrogen and here alkoxide. That is the answer. It is also CSR question. Now whatever molecules I am going to give, that all are repeated questions in exam. So try to understand, listen everyone, just concentrate. How many membered ring it is? 4 membered. 4 membered to 5 membered. Clear? Now how many membered ring? 1, 2, 3, 4, 5. It is a bicyclic compound. 5 membered right side. 1, 2, 3, 4, 5. 5 membered left side. 5 membered left, 5 membered right. What about here? Left side 1, 2, 3, 4, 5. Left side 5 membered, right side 6 membered. Okay? So when this is a condition, on that time it is possible. Means ring size should be get expand. Ring size if it is get expanded, then it is possible. Methanol. Now can I break above or below side? Is it sp2 or not? But what about here? sp3, break here. If I break this side, then 2 radicals will get, double bond you will get, right? Then solvent is given. Now break this pi electron. Radical, radical. Now this radical combine with this carbon. Then on that time, here oxygen, 2 electrons, electron, electron, double bond this one. So this and this join together. So here you will expect a 5 membered ring. Here 2 radicals will come. Then if I take methanol, break this. Here it is hydrogen and here it is OMA. This is DL question. Set examinations and DL examinations, Norrish I is most important, especially set. In set exams, 90% they are asking this kind of questions, and even photochemistry of olefins also they are asking. Cis-and stereochemistry or cis-and transition state question they are asking, especially in DL exams. Can I break this? Here it is methyl, and here also one more methyl. Here radical. This is acyl radical. So in this one what happens, see, don't write carbon intermediate. Now hydrogen transfer takes place from here. So when hydrogen transfer takes place, here this is methyl and here methyl. This hydrogen comes from here to here. Now this radical and here one more radical is left or not? This radical migrates and forms CH. This radical, there is a formation of what? So double bond O, ketene. Ketene formation takes place. After ketene formation, alcohol will attack on this carbon. So here you may expect back-to-back resonance. First go and back, it will migrate up. This hydrogen is added here, this oxygen will be added here. So finally this is the answer. This is methyl and here hydrogen. C double bond O, O-Me and here hydrogen. Here carbon intermediate formation not exists. Be careful. You will write ring here. You will write CH2, O, then that CH2 you will write hydrogen and O-Me. That is wrong. That is possible with monocyclic or bicycle. From tricyclic onwards, carbon intermediate formation never exists. Is it tricyclic ring or not? See, this side one ring, and here one more ring. If more than two rings are present, there is no carbon intermediate formation. Okay, see this hydrogen never intake this oxygen because it forms a tricycle. Right or not? Tricycles are more unstable as compared to bicycles. See, here how many rings are there? 3 rings. Right now how many are there? 2 rings. If this radical, suppose if I break here, if this oxygen combined with this one, how many rings? 3 rings. 3 rings with one more additional atom. Here see here how many rings are there? Here see, actually you will expect this answer. Right? You will write like this or not? But this is minor. This is not major. Possible, but this is minor. Because simple reason. Here it is a tricycle. Now you will get a bicycle. Bicycle giving a one more time tricycle. When bicycle give tricycle one more time additionally, by increasing number of atoms, that is not exist. Here see how many carbons are there right side? 2. Here how many are there? 3 or not? 1, 2, 3. One additional carbon or not? So preparation such type of tricycles are not easy from using a one more tricycle. I taken a tricycle, I am preparing a one more tricycle by increasing one additional carbon. This is not exist. That's why now intermediate is what? Ketene. Ketene attacks with this alcohol give ester. This is major. Because between tricycle and bicycle which is stable? Bicycle. Tricycle, bicycle. Is it bicycle? Now it is a bicycle. Between tricycle, bicycle which is stable? Bicycle is stable. Okay? Bicycle is more stable as compared to tricycle because more number of rings will give more strain. Here 3 rings are there, more strain. Here only 2 rings are there, strain reduced. But if you introduce this carbon, how many rings you are getting? 3 rings. That is not easy to prepare. You may ask one more question, sir. Last also bicycle be prepared. Without this, if I use this one, this I prepared or not? By using this molecule. By using camphor, here how many rings? 2 rings, bicycle. Now I want to prepare this one. This I prepared, right? By using last molecule. Bicycle to bicycle with increase in one carbon is more easy. Bicycle to bicycle by increasing one atom is more easy. Tricycle to tricycle By increasing one atom is impossible. Why? Because ring cannot survive. More rings are increases. Strain increases. So stability decreases. If any molecule having more than 2 rings, especially bicycle, tricycle, quintercycle, quarter cycle, like that I am saying. If more than 2 rings are present, if you keep on increase number of carbons, ring never survive. They are ready to dissociate. Okay, that's why in this ester is major, carbon is not intermediate. This product is possible. Whatever ring product is there, that is possible, that is minor. This you need to remember. If you know the ring properties, you will understand clearly. What is the answer? So can I break right side? If you break right side, you will get a radical and here one more radical here. Okay. Next, transfer of hydrogen takes place from alkyl to acyl, solution state. So on the time I will get double bond and here C double bond H. Okay. And one more product is also possible, but that is minor. You break this radical forms this one, and here there is a formation of this one. This is minor. If you break here, this radical form double bond. This radical combine and you will get this answer. This is minor. Many photochemical products are possible, but whichever is stable, that is major. Here one more product is also possible here, that is minor. This is minor. Why this is minor? See, here I am using, after getting alkyl radical, try to break towards that side. See, I am migrating this hydrogen, and here also can I break this hydrogen or not? Why am I migrating this hydrogen? Why not this hydrogen? See, if I remove this hydrogen, you will get how many substituted double bond? Tri-substituted. But here, how many substituted double bond? Di-substituted. Only 2 substituents are present. According to Zaitsev rule, as number of substitutions around double bond increases, stability increases. So this is more stable double bond as compared to this one. I am applying Zaitsev rule. Zaitsev product. Zaitsev Hoffman. Hoffman means less stable double bond. Highly stable double bond. Less stable double bond stable under thermally. Thermally this is stable. Okay. More stable double bond, more substituted double bond is stable according to Zaitsev rule. That's why normal elimination reactions will follow this. Pyrolytics in elimination we will follow this. So ISC Bangalore, this molecule is given an interview. What is photochemical product of this one? Always break toward that side where strain ring can open. Which is strain ring in this? 3-membered. 3-membered is more strain or not? So don't break above side, you need to open towards that side where strain ring have a facility to open. Suppose if I open above side or if I break towards this side Norrish I, that is also Norrish I, that side is not possible. Because if I open below side, this radical helps to break this 3-membered ring. Now I will get this kind of radicals. C double bond O radical and here 3-membered and this is methyl, right? Now two possibilities are there. So I can break this side and I can break this side. So if I break a direction A side, what is your answer? Direction A. See, if I break direction A side and this is direction B side, now this radical, double bond or not? Now I can write like this, C double bond O methyl, this is double bond, and what about this? Here I can get radical or not? I am not breaking towards B side. If I break here, this radical double bond, single bond as it is, this radical is present, this radical joins here. So once if it is joined, you will get this product. Can I? Now this is direction A. Now direction B. Direction B if I break. Now if I break here you will get radical and radical. This radical double bond. So this is, I can write like this. Here what you will get? One radical. If you break here, this radical double bond, right? If I break here without breaking this radical as it is, this radical double bond that I written. This is connected to carbon having 2 methyls, right? Then these 2 radicals are joined together. So after joining you will get that is the answer. Above one is predominant, this is major product, this is minor, this is major. This is CSR question. See, when nitrosyl is given, NO is given under photochemically. So photochemically this cleavage will take place and nitrosyl is going to be joined in between them. So you will get this insertion reaction. From there onwards, Barton reaction is possible to us. Photo-Barton. So when carbonyl compound photochemical nitrosyl is given, try to break Norrish I. Here you will get two radicals or not? This is one radical, here one radical. This nitrosyl having two radical, it will join the two. So this radical join with nitrogen and this radical also join with nitrogen. This is insertion, photo insertion. Norrish I followed by photo insertion. Photo insertion possible only when if they given nitrosyl oxide. Okay, break towards this side and insert this NO between the two radicals. It is also important. See, in this one you will get a radical like this. Now due to conjugation this radical is get stabilized here. So you will get double bond and this radical C double bond over radical. 1, 2, 3, 4, 5. So now this 5-membered formation takes place. These two join together. So after joining you will get 5-membered ring. That is the answer. So this you take down as homework. Take down as homework. Just write and leave it. So now I will explain this one, just listen. You take this 4 as homework, work out later. Take down this. See, it is a cyclohexanone, it is a spirocarbon. Is it alpha carbon or not? See, if any alpha carbon, beta carbon are ring carbons, if alpha carbon, beta carbon, ring carbons, Norrish I is not possible. Be careful with this point. If alpha carbon is a ring carbon or not, see, is this carbon present in the ring? Yes. Is it beta carbon present in the ring? Yes. Any one beta. At least one beta carbon present in ring, if it is shared by alpha carbon. If alpha carbon, beta carbon both are ring carbons, Norrish I is not possible. First cleavage takes place at beta bond. First cleavage takes place at beta bond. So first beta bond is going to cleave. After cleavage of beta, so you will get radical. Okay. Then see here one more beta hydrogen is here, break this. Now this hydrogen migrate from here, this radical, you will get double bond. So this is double bond and here you may get this. See. So if I break here, you will get one radical, and here see, you may get 1, 2 like this, right? If I break here, this radical as it is, CS to this. Now later on, this hydrogen migrates from here to here, beta. This hydrogen migrates here. This radical, you will get double bond. This hydrogen migrates from here to here. So you will get ethyl or not? That is the answer. Is it a Norrish I? Is it Norrish I? No. What is Norrish I? Cleaving alpha bond. Anywhere I cleaved alpha bond? This is alpha bond. This bond I not cleaved. This is not Norrish I. You will get different answer. Normal photo ring strain cleavage. If alpha carbon is a ring carbon, beta carbon is also ring carbon, Norrish I is not possible in that molecule. Okay, now see in this one, try to understand. Any one direction, if alpha, beta are ring carbons, not possible. See, is it alpha? Yes, is it alpha? Is it alpha ring carbon? Alpha ring carbon or not? Now, is it beta ring carbon? Not same ring, different ring it should be. Okay, so now this is beta. Forget about this beta. This alpha is a ring carbon of this one. This beta is a ring carbon of other ring. Then only it is possible. Not with same rings. You may also say here also it is beta ring carbon. Okay. So when alpha beta both are ring carbons of two different rings, break alpha beta bond. So after breaking this, now here methyl is there. Here one more methyl, here radical, can I? Now here one hydrogen is left, break this hydrogen from here, this radical, double bond, C double bond O, methyl, and this is methyl, that is the answer. This hydrogen migrates from here to here. This is not Norrish I. competitive with Norrish I. Looks like Norrish I, but it is not Norrish I. Means I am not breaking this bond. This bond is never going to be broken when alpha carbon of one ring, beta carbon of other ring, both are ring carbons. First we need to break that ring carbons only. These two are alls in set exams. So it is also approximately equal to epoxy-carbonyl. Even it is applicable for epoxy-carbonyl. See this. For this molecule also same concept. Is it epoxide? Photochemically solution state, what is the answer? You need to remember these miscellaneous reactions. Unexpected answer. Normally everything, now you are in Norrish I, you will think about breaking alpha bond only. But suddenly they will give one more ring which is shared by beta carbon. So that's why alpha beta carbons are ring carbon. That two different rings, not with same rings. Then Norrish I is not exist. First you break the ring carbons. Alpha, beta. Break these two. Here oxygen radical, carbon radical like this. Now break this. This radical join here. So you will get double bond and here it is OH. So now it is undergo tautomerism. So you will get dione, 1,3 dione. This is very important molecule for Grignard reagent. This is very important. 1,3 dione can be prepared by using this. Is it Norrish I? Is this molecule involved in Norrish I? No. Whether I am cleaving between these two? Whether I am cleaving here? No. Whether I am cleaving left side? No. If you are unable to cleave alpha sigma bond photochemically, that is not Norrish I. That bond never cleaved if there is a presence of strain ring shared by alpha and beta carbon. See, alpha beta shared by strain ring. Alpha beta carbon shared by strain ring. Alpha beta shared by strain ring. On that time, Norrish I not exist. This molecule many times asked in Grignard reagent. Very important. This carbon is more acidic center. It is used to prepare diamidone. Diamidones can be prepared by using to identify formaldehyde. Can I go for Norrish I? Is it alpha carbon? Now this is a beta atom. It is not Norrish I. If alpha carbon, beta carbons are ring carbons of two different rings, and if it is a strain carbons or strain atoms, Norrish I is not possible. Similar to this one, alpha beta. So then what is your answer? Same mechanism. You break here, you will get two radical, migrate this hydrogen, put double bond between these two. 1, 3, 1, 2, 3, 1, 3 dione. 1, 2, 3, 1, 3 dione. Alpha, beta, epoxy carbonyls never involve in Norrish I. They never involve in Norrish I. First they will prefer to undergo ring opening of epoxide. Then you will get diones. Diones are more stable than epoxides. That's why Norrish I is not possible. So this is last reaction. Now try to say whether Norrish I is possible or not. Norrish I possible or not? Here I am giving one statement every time. Based on that statement, say whether Norrish I possible or not. Is it alpha carbon? Is it beta? Alpha, beta present on same carbon, same ring? Yes. In this alpha, beta present on same ring? No. In this alpha, beta not present on same ring. Last example, see. This example also I given. Alpha, beta. Alpha, beta on same ring? No. This alpha belongs to 6 membered. This beta belongs to 3 membered. Is it alpha, beta belongs to same ring? Yes. Now Norrish I possible. So break this side, always open towards that side where ring is going to be open. Strain ring should get opened. Here radical, this is 3 membered. Here one more radical. Okay, so here I got a radical and this is the one. So break this bond. After breaking, you will get double bond, and here you will get one more radical and this radical. Can I? Break 3 membered ring every time. If any choice is there, break 3 membered. See. Here can I transfer hydrogen from here to here? No hydrogen, first of all, that carbon. This carbon having no hydrogen. That's why I am opening 3 membered. If I break here one radical, here one radical. So if I break this radical, double bond, this radical is left as it is. Then these two radicals are joined together. Then what is your answer? How many membered ring? 1, 2, 3, 4, 5, 6, 7. So can I write 7 membered ring? This is double bond and here it is this one. This is the answer. Is it Norrish I? Yes. Is it Norrish I? No. Is it Norrish I? No. Try to understand what is Norrish I. They won't ask Norrish I product. They will ask cleavage. See in your textbooks also, Norrish I cleavage they will mention, but they won't say Norrish I product. Cleavage is constant every time. Norrish I cleavage is constant, but Norrish I products are changes. Every Norrish I product never give, every Norrish I cleavage never give same product. That's why whichever is constant, that name is given. That is Norrish I cleavage. So not in any textbook they won't give Norrish I product. See, Zaitsev product is there, Hoffman product is there. Like that, there is no Norrish I product. Norrish I product changes, but Norrish I cleavage is constant. Whichever is constant, that name they will give. Norrish I cleavage. What is Norrish I cleavage? Norrish I, what is Norrish I cleavage? Carbonyl alpha bond cleavage. Carbonyl alpha bond cleavage is called Norrish I cleavage. Norrish I cleavage is constant, but products are changes. Depends on physical state, depends on solvent, your answer may be changes. Clear? So that is end of Norrish I. Norrish II. Norrish II cleavage. Also called En2. Photo elimination. Photo elimination reaction. Best example is Norrish II. En2 cleavage or Norrish II cleavage or photo elimination. C. Right. Transfer of gamma carbon hydrogen. Transfer of gamma carbon hydrogen on carbonyl oxygen followed by C alpha C beta cleavage. C alpha C beta cleavage in presence of light. So I am using light commonly. In presence of light is Norrish II cleavage. Norrish II cleavage nothing but transfer of gamma hydrogen on unsaturated carbonyl oxygen followed by C alpha C beta. So it is similar to McLaughlin. It is similar to McLaughlin rearrangement. McLaughlin rearrangement and this is remain same. So this is also similar to retro-in under thermally. This is retro-in reaction. Especially this is electronic impact. Beam of electrons are coming. When beam of electron comes, McLaughlin. Thermally, retro-in. Photochemically, Norrish II. If you know, these three reactions will be in your hand. One is McLaughlin. A beam of electrons interacts with a carbonyl having at least one gamma hydrogen, that is called McLaughlin. This I explained many times. Okay, then followed by retro-in. Thermally, same molecule if you participate in thermally, that is retro-in. And same molecule if you participate in photochemically, what is this? Norrish II. Norrish II photochemical, McLaughlin, beam of electron, retro-in, thermal. So based on condition, name changing. Molecule is constant. C. C. They produce variable products. Norrish II cleavage or Norrish cleavages produce variable products such as olefin, comma, enol, comma, cyclobutanol. So this is a key one. Cyclobutanol is key point. But most commonly, Norrish II possible with olefin and enol. This is not Norrish II product. Cyclobutanol is not Norrish II product. Okay, so they produce. This reaction will produce Overall reaction will produce 3 products commonly. Ene, nothing but olefin, enol. Olefin plus alcohol, and this is cyclobutanol. Only in Norrish II cyclobutanol possible. In MECLA-40 cyclobutanol is not possible. While you are learning Norrish II, most of the students they will focus on olefin and enol. Try to focus on cyclobutanol. Your question will come from butanol only. Because examiner are very well known that you are familiar with MECLA-40, Norrish II, retroene. That's why they won't target these 3. They will target cyclobutanol if they want to ask Norrish II. Very rare case. Suppose if any matching question is given, on that time they will ask cleavage question. Okay. So this is a actual reaction. Just see this. This is C double bond O, and here one more R. What is this carbon? Alpha, beta. This is gamma. Here gamma, how many hydrogens are there? So gamma carbon minimum 2 or 1 hydrogen is required. That is the first condition. Okay. So photochemical, if I irradiate, then what happens? See, this is called C alpha C beta bond. C alpha C beta. So now I am going to break here. I am going to break here. I am going to break here. Three cleavages. So if I cleave here, this radical, there is a double bond. This radical, there is a enol. And here R will be constant. And what is one more product? This radical, there is a cyclation takes place. This is O, R, and this is this. What is this? Cyclobutanol. This is called Norrish II product. This is Norrish II product. This is Norrish cleavage product. Okay, cyclobutanol. See, this is cleavage product here. This is cyclation product. It is a cyclization product, not Norrish II cleavage product. Norrish II cleavage product is this two only. Okay, this is a cyclation product only. Now, first we need to transfer this, then break this bond, break this double bond. See, you break this, and even you break this too. Transfer this hydrogen on oxygen, followed by C alpha, C beta, you will get 3 products. Alkene, enol isomerizes to give carbonyl compound. And this is called cyclobutanol. So everyone try to stress cyclobutanol in Norrish II. Next, go for characteristics of Norrish II. When Norrish II possible, Norrish I not exist. Forget about Norrish I. When Norrish I not possible, Norrish II not possible, Norrish I is exist. If 2 possible, 1 not exist. Be careful. You will get yield, but that is very poor. Here alpha carbon is there or not? Alpha bond is also there or not? But we are not going to discuss Norrish I. Norrish I is possible only if there is absence of gamma carbon. When gamma carbon with hydrogen is present, Norrish II possible. When Norrish II possible, 1 not exist. 1 not exist means don't think no reaction. You will get some yield. That yield is very poor as compared to Norrish II. In interviews they will ask like this. So gamma carbon is there in carbonyl, Norrish II possible. In that Norrish I possible or not? Say possible, but effective reaction is Norrish II, because Norrish II will give more fragments. As fragments increases, yield will be increases. More amount of reactant molecule can participate in reaction. Okay. Irradiate with suitable lambda of carbonyl compound. Next, reaction excited states are N2 pi star singlet and N2 pi star triplet. So triplet reactions are more effective as compared to singlet. Don't think singlet is not possible. Singlet is also possible, but triplet is more efficient. N2 pi star singlet R. These reactions are stereo specific. N2 pi star triplet is non-stereo specific. N2 pi star singlet stereo specific, triplet is non-stereo specific. Reaction eccentricity is singlet and triplet irradiated with suitable lambda like this. Then reaction intermediates are 1,4 biradicals. 1,4 biradicals. Reaction intermediates are 1,4 biradicals. Reaction intermediates are 1,4 biradical, irradiated with suitable lambda of carbonyl. Excited state is singlet and triplet, both are possible. Triplet is more efficient as compared to singlet. Singlet reactions are stereo specific, triplet reactions are non-stereo specific. Intermediates are 1,4 biradicals. Okay. If molecule having more than 1 gamma CH, so weak gamma CH involve in reaction. Weak gamma CH involve in reaction. So if more than 1 gamma CH is present, weak will be involved. Okay. 1,4 biradicals are stabilized by following methods. Stabilized by following reaction paths. Following ways we can stabilize 1,4 biradical. In PB reaction, which is intermediate, PB, Pattern-Bucci, 1,4 biradical. What are intermediates in Norrish I? Alkyl and acyl radicals. You need to compare. If you compare, then only you can remember. Otherwise, whenever if I come Norrish I, Pattern-Bucci will be disappears. Whenever if I come Norrish II, Norrish I will disappear. If I enter into photochemistry of olefin, total photochemistry of carbon will disappear. Only names will be remembered in your mind. Norrish I, Norrish II, PB, photo reduction, like that. Try to compare one concept to other concept in organic. Then only you can attempt questions. If you are unable to compare, only 50% you can attempt the question. First comparison. First recollect what is photo reduction. Try to recollect points. Then what is Pattern-Bucci. If you are not recollecting point, means you are not fit, first of all. Then Norrish I. How many points you are recollecting with Pattern-Bucci? Pattern-Bucci reaction, Norrish I, Norrish II, photo reduction, etc. Okay. Biradicals are stabilized by following ways. So first way, reverting into original molecule. It will revert into original molecule by abstracting hydrogen. By abstracting hydrogen means reversible possible. Reverting means reverse. It will give hydrogen from gamma, it will take hydrogen from oxygen. Where gamma carbon giving its hydrogen? Gamma carbon is giving hydrogen to which one? Oxygen. It will take hydrogen from that oxygen. Means it will give, it will take. In McLaughlin it is not possible like that. It will give but not take. But in photochemically, gamma carbon hydrogen is given to oxygen. Gamma carbon given hydrogen to this oxygen. Is it given or not? This hydrogen is coming from which carbon? This hydrogen is initially, is this oxygen having any hydrogen? No. But right now this carry one hydrogen. How it is getting? That hydrogen is given by gamma carbon. So gamma carbon can give oxygen, hydrogen, at the same way it will take hydrogen. This is possible in Norrish II. Okay, that is your first reaction. After giving hydrogen, there is a possibility of intake that hydrogen. That is first possibility. Next, second possibility. C alpha C beta cleavage to give olefin and enol. This is actually Norrish II. Norrish II cleavage. C alpha C beta cleavage possible. That is second possibility. Next, cyclization of 1,4 biradical to give cyclobutanol. This is proposed by Young. It is also called Young cyclization. YANG. 3 products are possible in Norrish II. But Norrish II, if they mention cleavage, Norrish II cleavage, write this answer. Norrish II reaction means all. Norrish II cleavage, only C alpha C beta, only this is possible after 1,4. What is intermediate in Norrish II? Intermediate in Norrish II is biradical. After biradical, 3 reactions are possible. First reaction, it will take its own hydrogen. Second reaction, C alpha C beta cleavage. Third reaction, cyclation. Out of these 3, which is Norrish II reaction? All are Norrish II reactions. Which is Norrish II cleavage? Norrish II cleavage. This one is Norrish II cleavage. This one is Norrish II cyclization. This is Norrish II abstraction. So generally in your books they will write only Norrish II they will mention. They won't mention total reaction. They will say Norrish II reaction. Norrish II reaction, Norrish II reaction products means these 3. 3 products are possible Norrish II. But if they mention Norrish II cleavage means real Norrish II cleavage is this one. If they mention the word cleavage, okay, apply only 2. If they mention was Norrish II cyclation, this one. Norrish II abstraction, this one. But if they mention Norrish II reaction means these 3 are Norrish II reactions. Way of asking is different. Concept is remain same, but you are not going to be clear on the word. Norrish II abstraction, Norrish II cleavage, this is real cleavage, and this one is Norrish II cyclation. What is Norrish I product? What is Norrish I product? They will ask like this in interview. In interviews, see, after cracking JRF examination, you need to face interview. If more than 1 candidates are competing with that requirement in front of any guide, so only 1 requirement is there. 3 people are arrived over there. 3 JRF candidates only. But only 1 requirement is there. You know that that guide is very good. So he was very transparent and they will give work clearly. So your PhD will be awarded in a less time. On that time many people will compete. 3 people came over there. 3 JRF students only. On that time he will not select based on your rank. Be careful. Your rank never helps in anywhere. Even if you are a first ranker in JRF, even if you are a last ranker in JRF, no one cares. So if you are a first ranker, they won't give any allotment for you. They won't give specialization for you. They won't give extra money for you. They won't give any extra fund for you. There is no special importance. There is no use of ranks first of all. Suppose if you write IET examination, suppose if you get first rank, what is the use? I am not explaining concept, I am giving one example. Right? You are listening very seriously. Sir is explaining any other concept. Maybe it is included in Norrish I or Norrish II means I am helpless. I am giving one example. It is not included in subject. Okay? So, suppose if you write IIT examination, what is the requirement? What is the eligibility for IIT exam? IIT examination. IIT, those who write intermediate students, those who pass intermediate, they are eligible to write IIT, not JAM. JAM is different, MSc, that is for MSc. I am saying intermediate, BTech. So intermediate students are eligible to write IIT. Once if you write IIT examination, some students are there. Lakhs of students are writing exam, but thousands of seats are available. So if you write IIT examination, suppose if you got a first rank in IIT, any use is there or not? What is the use? Preference, first priority. They will give first priority for you until and unless if you not taken your admission, they won't give priority for second person. Means they are giving first priority for you. Only for that priority only you are writing that exam. Not for qualifying. But CSR is only for qualifying. Suppose if you got first rank in CSR, what is use? Anyway you think about this one? Anywhere. Those who are qualified JRF students is there, na? You ask them. You got 40 rank or you got 4th rank, what is the use? You ask them. You got 4th rank, some other candidate got 198th rank or 400 rank. What is the difference between you and that person? Give one difference, at least one difference. You ask yourself or you ask that person, those who are doing research. You got 4th rank and same person, those who got 198, that person also doing research with same concept, with same guide, same fellowship, same time. Then what is the difference? No extra money, no extra fellowship. Then why you should develop more knowledge? Okay, so CSR is not about your rank. Remember, it is about your qualification of JRF. Even if you are a first ranker, even if you are a last ranker in JRF, you are same. Guide will select about your knowledge. Guide will make an interview. If more than one people facing that particular requirement, then definitely they will put one interview. In that interview, if you have a good knowledge on concerned topic, then definitely you will select. So, qualifying is better than getting good rank. Don't think about good rank. Okay, whether you are qualified JRF or not, that's it. How much rank you got, even if you are a first ranker, no use. Even if you are a last ranker in JRF, no use. Whether you qualified JRF or net, that's it. Okay, suppose see, a age-old person is there, more than 50 years or 55 years. And one person is there, young people, 28 years. Two persons are there. One 28 years, other 52. Now these two people are writing CSR exam. These two people, one first person is a young person who completed MSc and who took nearly 2 to 3 times CSR coaching. This person is ready to face CSR exam, 28 years. But this person, many years he has continuously teaching. He was not qualified. He was not qualified, but many years he was teaching. Even they teach for IIT students, MSc entrance he was teaching, and he was teaching for PG students, but he was not written even single time CSR. But you take an example, he was written but he was not qualified. After 52 years he was realized that I want to check myself, I want to write CSR exam. So out of 200 marks, both the two candidates are written. But this experienced person, once if they written exam, out of 200, he got 168 marks, just assume, first ranker. In CSR history, up to till today, no one got 168 out of 200. Just assume that this experienced person got 168, topper in CSR exam. But this 128 person got only 115 marks out of 200. Who will qualify in JRF? Who is eligible for JRF? 115%, not 168. This, even though this person got 168, he was qualified for faculty, not to do research. Clear? Even though they got 115, this person got 168, they won't give first rank. This 168 person not eligible to do research, they won't give any fellowship. Government never give fellowship, because your age is over, you are almost all in a saturated state. Then what you will do? You are doing research. That's why they will encourage young people. 52 years, is it possible to do research? Possible, but they want to encourage young people. But he was a first ranker, then what is the use? 168, he was not getting any rank in JRF, but he will get net. Net rank they will give. Net eligibility is there, but they won't award JRF for them. Even if you circle JRF plus net also, they will give net only. They won't give JRF. First they will see age. Age factor. That's why 28 plus 5 maximum for women's SC, ST and BC category. Maximum. And upper category always 28. It is the best age. So that's why give priority for young people for doing research, so that your knowledge expansion will be very high. Most of the students are going to be converted into scientists on the time. So try to learn subject clearly, so it may help in interviews. Norrish II products are depends upon the Norrish I cleavage. So we can't say what are Norrish I products, but Norrish I products are produced by decarboxylation, decarbonylation, disproportionation, dimerization. They are the Norrish II products. You can say, but Norrish I cleavage is constant. Okay, right. Next, you write one more point. You remember these 3 points in Norrish II. Reabstraction of proton, Norrish II cleavage to give olefin and enol, then finally cyclation. See, at alpha carbon, as substitution increases, cyclobutanol percentage increases. Only this point is important. See, if you want to get, this is major always every time. Norrish II cleavage is major. This is minor. But in your exam they will ask this one only. Even it is minor, they will ask this one. Because why they are asking this one? Even they won't ask this one. Maximum they won't ask this. They will ask either 2 or 3. Out of 2 and 3, 3 they will target. Why they are asking 3? 2 is most famous for McLafferty. McLafferty and 2 both are same. That's why they will target 3. 3 is a young cyclation, also called Norrish cyclation. So how to get this product? How cyclation product is measured? Cyclation product is measured only when, if I increase substitutions at alpha carbon. If alpha carbon having more number of substitutions, then this product increases, this product decreases. So I will show that relation, but right now remember, 3 products are possible, 2 is familiar, 3 is major only when, if alpha carbon having any substitutions. N to pi star, singlet possible, at the same way inter-system conversion, triplet also possible. Inter-system conversion, N to pi star, triplet, both are possible. So reaction possible from triplet as well as singlet. Now later on these two will give. So break this and break this. So after breaking here, that hydrogen will transfer on oxygen. Right? So this radical as it is and this radical as it is. What is this? 1,4 biradical. This molecule structure you need to remember. Very, very important intermediate in McLafferty. Norrish II. This is most important. First you need to remember this one. From there onwards your three products are expected. Intermediate in Norrish II is 1,4 biradical. 1, 2, 3, 4. 1,4 biradical. Now what is your first answer? Reverting into original molecule. How it is going to revert? See, this radical one more time take this hydrogen. So on that time what happens? This hydrogen migrates from here to here. So after migration, here two radicals are left. This radical combine together and forms double bond. Is it original molecule? This is possible. That will decrease the percentage. Okay, next possibility. So next possibility, this is called Norrish II cleavage. What is Norrish II cleavage? So now this here I am cleaving now. If I cleave here, this radical, what will get? A double bond or not? This radical, double bond, this radical, double bond. So this is ene plus enol. This is enol and this is ene. That is Norrish II cleavage. Then last product. What is your last product? Cyclization, young cyclization. Now see, these two radicals are directly interlinked together. This radical combine together and forms a 4-membered ring. This is OH and this is R. Now three products. So be careful with 1,4 radical. This you need to keep in your mind. In your examination while preparing Norrish II, first remember 1,4 biradical. If you transfer hydrogen, one product. If you combine these two radical, one product. If you break here between C alpha and what is this? Alpha, beta, gamma. If you break bond between C alpha and C beta, that is called Norrish II cleavage. That is this one. This direction is also called McLafferty. This is reversible reaction. This is cyclation, young cyclation. So take up to here. So we are closing class today. Take this mechanism for Norrish II. So remaining part we will discuss in your next class. Applications will be there. See, one point explain. In this which is major? This is major. Norrish II major. This is minor always. This is major only when if this alpha carbon, you focus on this alpha. If this alpha carbon having more number of substitutions, then only this is major. If this carbon having minimum 2 substitutions, minimum 2, then this is major. Even if this carbon having one substitution, this is major. That depends on size. But maximum, which is major? Norrish II cleavage. So, but they won't ask Norrish II cleavage, they will ask this one. Suppose if they ask any Norrish II cleavage, they will ask comparative questions. They will give left side some molecule, right side some molecules. Left side names they will give, right side their products they will give. Match the following on the time they will give Norrish II cleavage. But remember, Norrish cyclation is this one. Okay? We'll stop here, we'll continue next class. So evening schedule will be announced in your WhatsApp group. So morning remain same. Tomorrow morning time remain same.